Hello and welcome to your reteach for Newton's Laws. So what you're going to do in order to receive credit for this reteach is watch the video in its entirety, and you can either fill out your notes on the worksheet that your teacher gave you and answer questions on the worksheet as well, or you can get a digital copy from your teacher where you can type in the notes and answer the questions digitally and then email it back to your teacher. The choice is yours. So let's get started. Newton's laws are named after Sir Isaac Newton, who explained how objects move. Newton's first law is called the law of inertia. Newton's first law states that an object at rest will stay at rest, and an object in motion will tend to move in a straight line at a constant velocity unless acted upon by an unbalanced force. Inertia is not a force. Inertia is the object's resistance to change. Please watch the following video to learn more. Now let's observe Exhibit A. We'll call him L. When we think about inertia, it has a tie-in with the mass of an object. The more mass an object has, the more inertia or laziness it will have. In other words, bigger objects with more mass are harder to start and stop. You've learned that the more mass an object has, the more inertia it will have. Remember, inertia is the tendency of an object to resist a change in its motion. It is not a force. So because L has a large tendency to resist a change in his motion, when Dominique tries to change his motion by applying a force, she's not able to. Because he has a large mass, he has a large amount of inertia. The second part of Newton's first law states that if an object is already in motion, it will stay in constant motion forever unless acted upon by an unbalanced force. As you saw earlier, an object with a large mass has a large amount of inertia. Therefore, it is harder to get that object to get moving. However, the opposite is also true, as demonstrated by L and Dimitri. Once an object with a large amount of inertia starts to move, it is harder to change its speed or direction. Now let's talk about Newton's second law, or the law of force and acceleration. This law states that an object's acceleration depends on the mass of the object and the amount of force applied. This is the law that goes with the formula force equals mass times acceleration. For this reteach, we will focus on how each of the variables are related to each other and not on the calculations. Remember, you already tackled the calculations on our force and motion test you took about 2 weeks ago. Let's discuss acceleration. Remember, we covered this on our last test. Acceleration is a change in velocity. Friendly reminder, velocity is speed in a particular direction. So, acceleration happens to an object when you change its speed, direction, or both at the same time. Mass is the amount of matter in an object. Let's talk about acceleration and force. The more force an object has applied to it will cause more acceleration. Acceleration and mass are related because the more mass or inertia an object has, the more force it takes to move the object. Force, mass, and acceleration are related to one another. If the mass remains the same, the more force you put on an object, the more it will accelerate. Please observe as L applies a small amount of force to Ari. Now observe what happens to the acceleration when L applies a larger force to Ari. Now let's explore What happens when the force remains the same, but the mass changes? We'll start with Dimitri, who will represent our lighter mass. Let's see how his acceleration is affected when a force is applied. Now let's see what happens to the acceleration when the force remains the same, but the mass of the object is increased. As you can see, the changing of the speed or direction of the object has greatly decreased because the mass has increased. Remember, you know you are looking at a Newton's second law question when it usually has you compare two objects. Whenever you see a question like that, ask yourself, what happens when I change the force? What happens when I change the mass? Or ask yourself, what happens when I change the acceleration? Remember, kids, acceleration is not about how fast an object is going. Acceleration is a change in an object's speed and direction. So when you have two objects like Elle and Dimitri, ask yourself, which one would be easier for you to accelerate? Newton's third law is called the law of action-reaction. It states that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force back on the first. Forces are always produced in pairs called the action-reaction pair. The action-reaction pair move in opposite directions with equal strength. Please watch the next 3 videos that covers Newton's first law, the law of inertia, Newton's second law, the law of force and acceleration, and Newton's third law, the law of action-reaction. After watching each video, please take the quizzes as a way to formatively assess if you're ready for your retest or not. Thank you and have a good day.
Hey, can you give me a hand?
Nah,
Oh, RJ, this sofa's heavy. Can you help me move it?
I'm reading something. Can't we do it later?
Man, talk about inertia.
Inertia? What do you mean? I'm just chilling.
More like frozen in place. A perfect example, since inertia has to do with how things move. Or don't. It's Isaac Newton's first law of motion. The first part says that because of inertia, objects in motion will keep moving at the same speed in the same direction.
Forever?
Yep, unless some force changes their motion.
Come on. How can something keep moving forever?
Well, think about Mia on her scooter. Once she starts rolling, she just keeps on going.
Yeah, until she runs into some gravel or something.
That's because gravel causes friction. It makes her slow down and stop.
Yeah, but she would have stopped eventually.
Not if there wasn't any friction or another force to stop her. That's the most important part of Newton's law. If Mia was zipping along in outer space where there's no friction, once she started moving, she wouldn't need another force or push to keep her moving. She'd just keep going at the same velocity forever.
Velocity? Isn't that like speed?
Well, speed and direction.
Wow. Can you imagine Mia going straight out into space?
Now that would be a trip. Speaking of trips, inertia is what makes you slide sideways when you're riding in a car that makes a sharp turn.
Really?
Oh yeah. When you're driving along, even though you don't feel it, your body's moving as fast and in the same direction as the car. If the car turns fast, your body keeps moving in the direction you were going before the turn. So if you're turning left, you'll slide to the right. See?
That's wild. I think I'm getting it. But what about the sofa? You said it has inertia, but how? It's standing still.
Yeah, and so's the scooter after it stops. Lucky for us, Newton discovered that the same rules work for all objects. So part 2 of Newton's first law says that because of inertia, objects at rest will stay at rest unless a force makes them move.
What kind of force?
Well, Mia can push off with her foot to get enough force to start moving again.
So how come you couldn't make the sofa move?
Well, the heavier things are, the more inertia they have, and the harder it is to make them move.
That sofa is really heavy.
That's why I needed your help?
Yeah, I get you. So let's go over this inertia thing again. I want to be sure I've got it. Newton's first law of motion says that because of inertia, objects in motion will keep moving at the same velocity, that's speed and direction, and objects at rest will stay at rest, unless a force changes things. Friction is one kind of force. It can make a moving object slow down or stop. Heavier objects are harder to move or stop because they have more inertia.
Impressive, RJ. I think you got inertia down.
Thanks. Now, how about I get over it and help you move that heavy thing?
Well, I don't want to force you, but I'd love it.
Look at that ball go! I don't know how you do it.
Just a little luck and a lot of acceleration.
Acceleration? You mean speed?
Nope, acceleration. Speed's just a measure of the distance something travels in a certain amount of time. Acceleration is a change in velocity, both speed and direction.
Oh, I guess that is different.
Definitely. Every time that ball gets knocked by a flipper, takes a sharp turn, or hits a bumper, it either speeds up, slows down, or changes direction. That's acceleration.
Wait, it's accelerating even when it slows down?
Even when the speed is decreasing, it's still acceleration, but you can call it deceleration instead of acceleration.
Whew, that's a lot of speeding up and slowing down. But what about before all that, when the ball's just sitting still?
Well, when an object is at rest, that's partly inertia at work. Inertia is the property of matter which states that an object at rest or moving in a straight line stays that way.
So, does that mean inertia slows things down?
Not at all. Inertia is what keeps things steady, whether they're moving or not. It's the constant speed of an object. What you're thinking of is friction.
What's the difference?
A lot. Friction is a force that works against a moving object, like when you ride your skateboard over gravel on the road, or when the pinball is slowing down as it rubs against the wood on the flat parts. Those are both examples of friction and how it slows things down.
So, if inertia keeps things steady, what gets them moving in the first place?
To get something moving, we need force. To start, the ball is sitting still, waiting to be rocketed into the game.
Waiting for force.
Yeah! The force is a push or pull that causes an object to move, stop, or change direction. When I launch it,
Bam!
I apply an unbalanced force, a force stronger than the one keeping it in place. When an unbalanced force is applied to an object, its velocity changes and acceleration occurs.
Nice! It went from sitting still to full speed ahead in a split second.
Right. When there's an abrupt change in velocity like that, that's when acceleration is at its peak.
And every time it changes direction, that's acceleration too?
You got it.
Whew! Acceleration's quite a ride, but I think you got me up to speed on what's happening here. Acceleration is a change in velocity, the speed and direction of an object. When a force is applied to an object that changes the object's direction or speed, acceleration occurs. And until that change happens, inertia's always at work, keeping an object at rest or moving in a straight line.
Sounds to me like you're all up to speed when it comes to acceleration, Sam. But now it's time to excel where it counts.
Ow.
Zoe, watch out!
Ouch.
Hey, are you okay?
Yeah. Oh, hard bench. Guess I wasn't looking.
Now that's what I call action and reaction.
Action and what?
Action and reaction. It's Newton's third law of motion.
What?
You know Isaac Newton, the gravity guy? He realized that for every action, there is an equal and opposite reaction.
Like, if I run into you, you run into me at the same time?
Pretty much, but there's more to it. Okay, so when you bumped into me, you applied force or pressure against me.
Yeah, sorry about that.
According to Newton's law, my body pressed back against you with the same force.
Come on.
We both felt the same force because the forces from our bodies pressed in opposite directions.
Yeah, but if we hit with the same force, how come only I got knocked down?
Good question, champ. It's all a question of mass. How much matter is in something? First of all, who has greater mass, you or me?
Is that a trick question? You, obviously.
Well, according to Newton, when two objects with different mass collide, they'll accelerate at different rates,
Accelerate?
change their speed and direction.
So, even though their forces are the same, one will accelerate more than the other?
You got it. The object with smaller mass will accelerate more.
Smaller? That would be me. So I fell, and you didn't.
Hey, come to think of it, the same thing happened with you and my soccer ball. You hit each other with the same force, but the soccer ball went flying.
I got it now. Because my mass was bigger, the ball accelerated more. How about when a baseball bat hits a ball?
Yep, both objects hit each other with equal force in different directions. The ball goes flying because its mass is smaller. The way the bat is moving when it hits can make the ball go in different directions.
And what happens when two things that are the same mass collide? Like two pool balls?
Well, what do you think?
Well, they hit each other with the same force, and the forces press in different directions, so they have the same acceleration?
Yeah.
Wow, this action and reaction thing is a little complicated, but I think I've got it. Newton's third law says that for every action, there's an equal and opposite reaction. That means that when two things collide, they press with the same force in opposite directions. That's why you and I both felt it when we bumped into each other. And when the objects have different mass, like we do, they'll also have different acceleration. The object with smaller mass, in this case me, will speed up or accelerate more.
And she scores. Now that's what I call a smart reaction.
What can I say? I'm just a genius in full force.